Okay, so let's go over this. Identify the functional groups for the following. So you have a halogen here, an alkene here. So which functional groups will we have here? Alkene and bromo alkane, or you can just say halogenoalkane. Then here we have chlorine, alcohol, and this right here is the aldehyde functional group. So you have aldehyde, alcohol, and chloro functional group, or you can call it a halogenoalkane. Then here you have alkene and carboxylic acid. So you have carboxylic acid and alkene. Then here you have a ketone, and this right here is an alkyl side chain. Do you see alkyl sticking out right here, CH3, one less hydrogen than alkane. So this right here is ketone and an alkyl. You have an iodo, OH, alcohol, and that is an alkyl. So you have alcohol, alkyl, and halogenoalkane. All right, this one has alkene, chloroalkane, acid. So you have carboxylic acid, alkene, and halogenoalkane. Then here you have the ester linkage. So this right here is the ester group. BrCH3 aldehyde. So this has aldehyde, halogenoalkane, alkyl. And here you have a ketone, alcohol, iodoalkene. So you have ketone, alcohol, and halogenoalkane. Clear? Any questions so far? Do you all know how to identify these? Now let's get to the naming of organic compounds. So let's see naming of organic compounds. Let's first take 3 carbon compounds. So you have, I'm not putting the hydrogens. So let's try naming all of these. Let me just draw them first, then we will name them. So let's name organic compounds. I've drawn these 3 carbon compounds. Let's now name them. So this right here, the first one is a 3 carbon. If you can see, all carbon-carbon bonds are single. So 3 carbon alkanes, this would be called what? Propane. Then you have a 3 carbon alkene. This would be called what? Propene. Now, you can call this propene, or more precisely, you can see that this is your longest chain of carbons, yes, and on carbon 1 and 2, you have your double bond. So we call this what? Prop 1ene, because your double bond is between carbon 1 and 2. So you pick the smaller number, and you can also call this prop 1ene. So you have your longest chain, 3 carbons. You number your carbon atoms. So this comes out to be 1, 2, 3. Now you'll be like, Miss, can we number it from the other side? No. When you pick your longest chain, you got a number such that the functional group gets the least number. So alkene should get the least number. So you have to make this 1, 2, and 3. Clear? Now, likewise here, we have 3 carbons. Alcohol is the functional group. It should get the least number. So you number this carbon as 1, 2, 3. Yes? And this will become what? Propan 1 all. Or you can call this propanol. Whenever the functional group is attached on carbon number 1, you don't necessarily have to mention the 1, but it's good practice to mention the 1 so that next time it's on any other carbon, you don't forget to add the number. Like for example, in D, if you see, you have 3 carbons here, yes, and on carbon number 2, you have the alcohol. So this will be what? Propan 2 all. So this is propan 2 all. Then you have a 3-carbon aldehyde. Do you see carbonyl carbon with carbon on one side and hydrogen on the other? So this would be what? Prop, because it has 3 carbons. And because all carbon-carbon bonds are single. And al, because it's an aldehyde. Or you can say propan 1 al, because aldehyde is on carbon number 1. Because when you pick your longest chain, this will be carbon 1, 2, 3. And aldehyde is on carbon number 1. Then we have this. It's a ketone. And if you see, wherever you number from, whichever side you number from, the ketone comes on carbon number 2. So this would become what? Propan 2 on. Prop, because 3 carbons, and because carbon-carbon bonds are single, 2 on, because the ketone is on carbon number 2. Let's see this. Now you have carboxylic acid. Again, main chain is of 3 carbons. Acid will be on carbon 1, 2, and 3. It will be on carbon number 1. So you will call this propan 1-oic acid. Now you have this main chain again, 3 carbons. You have a nitrile which is on carbon 1. So we will call this what? Propane nitrile. What will we call this? Propane nitrile. Or you can call it propane 1 nitrile. Then you have the amine functional group. Again, on carbon 1, you have the amine linkage. So this will be what? Propyl amine. Or propyl 1 amine, that's also fine. Then you have ester linkage. Now, this is not acid, guys. You'll be like, Miss, oh, shouldn't this be acid? No. In acid, you have the O with the H, but the O and H are not together. So this right here is the ester linkage. I told you everything after the C single bond O, that is this bit, comes from the alcohol and is written first. So that would be ethyl, and everything before it comes from the acid and is written later. So 1 carbon, that would be methanoate. Ethyl methanoate. Is this clear? So let's go over the naming of these 4 carbon compounds. So this right here is a 4 carbon alkane. So we will call this what? Butane. This right here is a 4 carbon alkene. We will call this what? But1-ene, because you have this chain and the double bond is between carbon 1 and 2. So this becomes but1-ene. Then this right here has the alkene between carbon 2 and 3. So you pick the smaller number. Between 2 and 3, we will call this but2-ene. And this right here is an alcohol, where the alcohol will be on carbon number 1. So we will call this what? But, because four carbons, and because all carbon bonds are single, butane one all. Then this right here is butane two all, because you have four carbons on carbon number two, you have the alcohol, so this is butane two all. Then this right here is a chloro on carbon number two, so we call this 2-chloro butane. Yes, because it's a halogenoalkane. So 2-chlorobutane. Then you have a ketone right here. And this is a 4-carbon ketone where the ketone will be on carbon number 2. So we will call this butane 2-one. Then you have an aldehyde right here. Aldehyde is on carbon 1. So you will call this butane 1-al. Then you have this again an aldehyde on carbon number 1. This is also what? Butane 1-al. Then we have this linkage right here, the ester linkage. Everything after the C single bond O comes from the alcohol and is written first. So 2 carbons, therefore ethyl, and 2 carbons here for the acid, therefore ethanoate, ethyl ethanoate. And this right here is carboxylic acid, a 4-carbon acid. So you call this butane 1-oic acid or butanoic acid. Now, if you see the naming, guys, between a letter and a number, you always put a dash. Do you see that? So between a letter and a number, you always put a dash. Yeah. Between two numbers, you always put commas. Now let's get to this was simple naming. Yeah, I hope this was clear. Does anybody have any problem in any of these? Do you? Now we will go over the rules for naming organic compounds. So, so rules for naming organic compounds. Let's see. First rule is that you got to pick the longest carbon chain. So pick the longest carbon chain, which is called the parent chain, including all functional groups. So you must pick the longest carbon chain, including all functional groups. For example, you have this, let's say, this is your organic compound. Now you got to pick the parent chain or the longest carbon chain. That's the first step. Now, how do you pick the longest carbon chain? You start from one end and you go to the other without overwriting, without overtracing. You pick it in one sequence, in one go, basically, right? From one end to the other. And let's see. You'll be like, oh, 1, 2, 3, 4, 5. This is the longest chain. No, this right here, 1, 2, 3, 4, 5, 6. This is the longest chain. Now you'll be like, Miss, can we do this? 1, 2, 3, 4, come back up, 5, 6, 7. No, you can't do it like this. You can't go like this and then come back up and pick the chain. No, it has to be in one direction, in one go. So this becomes your longest carbon chain. Clear? It is 1, 2, 3, 4, 5, and 6 carbon atoms. So this becomes your longest carbon chain or your parent chain. Let's see another example. Let's see another example. Let's see another example. So you have 1, 2, 3. All right, let's see this. All right, now you have this. Now let's pick the longest chain. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. Now 1, 2, 3, 4, 5, 6, 7. Now you have two ways where you're getting a 7. You're getting a longest chain of 7 this way, and you're getting another one, which is this way. Which one will you pick? Your parent chain must include all functional groups. So you can't pick this one because this is not including acid. So you must pick the one with all the functional groups in it. Therefore, you will pick this one with carboxylic acid included in the chain. And this becomes your longest carbon chain. Clear? So you have 7 carbons over here. You have 6 carbons over here. Let's see another example. All right. So let's see this. You have the longest carbon chain. So you have 1, 2, 3, 4. No, not this. 1, 2, 3, 4, 5, 6. Okay. 1, 2, 3, 4. No. We've already got one for 6. 1, 2, 3, 4. No. This becomes your longest carbon chain with 2 carbons here, 3, 4, 5, and 6. And you see it includes all the functional groups. So the first thing is you pick the longest carbon chain, which we call the parent chain. The second is you will number the carbon atoms in the parent chain. So you number the carbon atoms in the parent chain such that the most important functional group gets the least number. So the most important functional group gets the least number. Now you will be like, how do we know which one is the most important? So right here we have the list of importance. The most important is carboxylic acid. So this will always get the least number if it is present. Then you have esters. Then you have amine. Then there is nitrile. Then there is aldehyde. Then there is, you need to remember this list so you can number accordingly. You have ketone, you have alcohol, then there is alkene, there is alkane, there is alkyl, and you have halogenoalkane. So this is the most important, and this is the least important. Now let's see an example. So you have example 1. Let's see. The first thing is you pick the longest carbon chain. Yes. And then you number your carbon atoms such that the most important functional group gets the least number. So let's pick the longest chain. The longest chain would be this. This is your parent chain. 1, 2, 3, 4, 5, 6, and 7. Sorry, 6. So you have 1, 2, 3, 4, 5, and 6 carbons. So this is your longest chain. Now you number your carbon atoms such that the most important, which is the most important functional group between carboxylic acid and alcohol, Which one is the most important? Carboxylic acid. So it should get the least number, therefore you will number from this side. Clear? An acid will be on carbon 1 and alcohol will be on carbon number 3. Clear? Let's see another example. All right. So let's see this. You first pick the longest carbon chain. The longest carbon chain right here, you can see is 1, 2, 3, 4, 5, 6, 7 carbons. Now, pick the most important functional group. Alcohol here is the most important because halogenoalkanes have the least importance. So alcohol should get the least number. Now, wherever you number from, you see alcohol gets carbon number 4. If you number from this side, alcohol gets carbon number 4. If you number from this side, alcohol still gets carbon number 4. So then you will take the second most important, for example, halogens. If we number from this side, then this will be 4, this will be 5, this will be 6. Yes. So what we do instead is we take this side because alcohol anyway will be 4, but this way the halogens will get the least number as well. So this is a better way of numbering. Yes. So you pick the longest chain and give the most important functional group the least number. Let's see another example. All right, let's pick the longest chain here. So the longest chain here would be 1, 2, 3, 4, 5. Or you can take 1, 2, 3, 4, 5. Either way, it is 5. Either you take this or you take this. Both are 5. So let's go with the straight one. Both will give you the same compound, whether you take this or you take this. Both are 5, the longest, including all functional groups. Now you got a number. Alcohol is the most important functional group here, so it should get the least number. So this will be 1, 2, 3, 4, and 5. Clear? Is this clear? So this is the second rule. Then let's move on to the third rule of naming. The first was pick the longest chain or the parent chain, including all functional groups. The second rule was that number the carbon atoms such that the most important functional group gets the least number. The third rule is if a compound has a functional group appear more than once. So if it has a functional group appear more than once in a compound, so if you have a functional group appear more than once in a compound, we use the prefix di, tri, tetra. So di means 2, tri means 3, tetra means 4. So if something appears more than once, you use the word prefix di, tri, tetra. For example, you have this. For example, we have this right here. Now, first thing, we will pick the longest carbon chain. 1, 2, 3, 4, 5, 6. Second, we will number the carbon atoms such that the most important gets the least number. So this is the most important. 1, 2, 3, 4, 5, 6. Now you will name them, right? So the most important functional group is what the compound actually is. If I ask you what is this compound, you will say this is an acid because that's the most important functional group here. Now let's name it. This is an acid, so the name should end at acid. All right. It's like saying, you know, how people have, like, if, for example, you have an Ahmad, right? So it will be Muhammad Ahmad. So, or Sayyid Muhammad Ahmad. So all the Sayyid and the Muhammads are the side chains, all the extra stuff that is attached to the organic compound. But you basically call the person Ahmad, not Sayyid, not Muhammad, right? So you call them Ahmad. So just like this compound is an acid. So you will call it an acid. Everything else will be the Sayyid and the Muhammad and the XYZ random stuff attached before the actual name. So you have a chloro on carbon 2. You have two chloros on carbon number 3. So we will call this 2, comma 3, comma 3. Between the number and another number, you always put arrows. So between two numbers, you put commas, sorry, not arrows, and between a letter and a number, you put dash. Yes. So you have 2, comma 3, comma 3. How many chloros do we have? Trichloro. Because you have 3 chloros. So we will call it what? 2, comma 3, comma 3 trichloro. 6 carbons mean it is hex. Yeah. So hex because 6 carbons. So you've named this, you've named this, you've named this. Now you've talked about the main chain, which is 6 carbons. So that's hex. All carbon-carbon bonds are single. That's why hexane, right? On carbon 1, you have the acid. So hexane 1-oic acid. You can also call it hexanoic acid. So this will be 2, comma 3, comma 3 trichloro hexane 1-oic acid. Is this clear? Now, there's also another rule, which is that halogens are always named first. These are the least important, but they are always named first. You always, if in a compound you have halogen and other functional groups, you always put the name of the halogen first. Clear? Let's see rule number 5. So you have, if you have variants, if variants of functional group, so if variants of functional groups appear in a compound, and I will just explain what that means, name them in alphabetical order. So you name in alphabetical order. For example, if you have, this, so you have 6 carbons in the main chain. So let's see, we have all right, let's pick the longest chain. 1, 2, 3, 4, 5. No. 1, 2, 3, 4, 5, 6. Yes. 1, 2, 3, 4, 5. No. The longest chain is 6 carbons. Yes. So this is your longest chain or the parent chain. Now you will number your carbon atoms such that the most important functional group gets the least number. So carbon 1, 2, 3, 4, 5, 6, because acid is the most important. Now, if you see, you have variants. Now, I told you halogens are always named first. If I ask you, what compound is this? This is an acid. Now, halogens are always named first. So which halogens do we have? We have chloro, bromo, iodo. Now, if you have variants of a functional group in a compound, you name them in alphabetical order. So so you have bromo, chloro, and iodo. Which one comes first alphabetically? Bromo. So you will call this 2 bromo. Then what do we have? 3 chloro, 3 iodo. Do you see? We are naming alphabetically. Between a letter and a number, you put a dash. So you name this, this, this. Now you also have an alkyl sticking out on carbon number 4. So you will call this 4-methyl. So you've named this, 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 and this. Now you have the main chain of how many carbons? 6. So you have hex. All carbon-carbon bonds are single. That's why and on carbon number 1, you have the acid. So hexane 1-oic acid. Is this clear? So these are the rules for naming. Pick the longest chain or the parent chain, including all functional groups. Then you number the carbon atoms in such a way that the most important gets the least number. The list of importance is right here. Then, if a functional group appears more than once, you use the prefix di, tri, tetra. Halogens are always named first. If variants appear in a compound of the functional group, you name them in alphabetical order. Clear? Is this clear?